Ian Crossland, welcome to Hard Truths, man. How are you doing today?
Great, dude.
Yo, first question. Do you know what these cards are over here?
No.
Can you
Well, I
tell
know
what
they're
those are?
I know they're magic. I thought they were magic cards. I couldn't tell if they were magic or Pokemon, but I thought they were magic cards. But what I can't tell what cards they are. Are they? What are they?
How dare you judge me? Think that I'm a Pokemon card player?
No, I
We
know you
played Magic
Yeah.
cards.
But did you play Pokemon?
I played Pokemon Go. So, like, yeah, okay, but I didn't play Pokemon cards or whatever. But
Okay.
so I was a kid and I played. I grew up with Magic cards, but like I never really like played, in the '90s. And then as an adult, I kind of got into it. And actually, Wizards of the Coast sent me that uncut sheet right there. That's War of the Spark, the one with all the planeswalkers in it. I don't know if you
Whoa.
remember, but I
No.
bought some stuff from them, and they like messed up the order, so they sent these cards up there.
Whoa.
I just think it looks really cool, so I got it.
It looks amazing, dude. Are they foil?
Yeah, they're all like the foil planeswalkers.
Oh, that looks
or
so
whatever.
good.
So, I don't know. I didn't, and I just lean into being a nerd anyway. I'm not ashamed of it at all.
Yeah.
You know?
And it's
So,
mathematics, Magic the Gathering. It's just math with the colors and pictures of dragons and shit, but it's all math.
Yeah, let me ask you that. That brings me to kind of my first question: is have you ever heard the thing about like? I know you're a musician. That mathematicians, when they were asked what study do they most relate to, I think that they overwhelmingly agreed music was the answer. Have you ever heard that before? Do you agree with that?
Yeah, I have heard that. It works with me too, especially geometry. I think of music as like spatial sound, spatial awareness, moving. I think of a lot in terms of momentum and like pattern. Like when you walk across the room, it's like a pattern. I see like a pattern of motion, and so I hear that when I hear sound like da da da. I can picture it 1, 3, 5, and I see it on a graph, and that's just like a line graph. I can picture the shape of the sound, but then you can actually hear like the wholeness of tone as well. And it kind of creates these like spherical, canonical shapes and things like that. And I think a lot of it is like filling space, similar with cooking. You want to like make sure there's enough seasoning in all the little parts of the bowl, and that no part of the thing is too hot, that all the temperature is evenly dispersed. So it's kind of with sound is similar.
The other thing that reminds me of is I think this is something that we talked about on the podcast when we were on Culture Wars, was like waves versus particles. Is that when you think of sound like that, when you think of, you're really describing waves, in my opinion. It's like the up-down motion is like this resonance kind of that's out there. I think that the question is matter a wave? Can matter be a wave? We stuck in this particle mindset where everything must be this definite thing. But is it possible that we are just a complex series of waveforms, but that there's some other explanation? Do you agree with that kind of viewpoint, that esoteric viewpoint?
Yeah, and after Wei Ping, you came on, and you came on the Culture War, I started thinking a lot about subatomic spin and like what's causing it. The scientific community thinks maybe was it angular momentum, but then they're like, no, because that would mean that these two vortices are traveling the speed of light, which is not possible. So what is it? They don't know. I think it's cymatics, that there's a vibration of space-time that's causing the position of the subatomic space to face left. And then the frequency changes and it faces north. Then it changes again, it faces east, faces south as the frequency changes. But the frequency is changing so fast that it looks like it's spinning. And so there's some maybe not imperceivable vibration, but I think eventually we'll end up being able to measure what's causing shape to snap to that form.
No, that's a good way to put it. And so we're talking about quantum spin, and we know there is spin when we look at particles at the quantum level, because we can see like the perturbation and we can measure that. Like we can put electromagnetic fields next to them. We can see these things react. So we know that there must be this quantum spin, but then it's like, what does that actually mean? You could watch videos all day of people online trying to explain quantum spin, but end of the day, it's like we know it has the properties of something that's spinning. But at the same time, we think of it as just this like quantum kind of magical, a dot, this particle. So it's hard for us to wrap our brains around that. I think one other thing that could open the door to that is something that we talked about on the podcast too, which is the ether. It's like the idea of this extra dimension that was thrown out, like 100 years ago. Because if there is this spin that's happening, if there is some effect that's happening, where's it coming from? What's causing that to happen? And surely there must be some force kind of pushing on it from some direction to cause it to spin, or for something like that to happen. Have you had any thoughts about the idea of the ether and extra dimension at all?
Well, Yeah, but what does that mean exactly? What is ether exactly? Is that the fabric of space-time? Is ether? They think it's an actual fabric?
So not
Or
really.
pool
Like
or-
we've kind of moved away from this like fluid medium. I mean, it really would be a super fluid. If you were to really describe, there's a lot of different ways to describe it, but you could say that space-time itself is like a flexible solid. So it can like it's solid, but it can move. It can jiggle a little bit. Like it's connected, but it can move around. Leonard Susskind, who's written, has kind of popularized ER equals EPR. I think he would call it like anti-de Sitter space. So it's almost like a counter space. So like you have this, the universe is trying to expand, you know, at the same time you have this force pulling it together at the same time. So, but that's more, I don't know how he geometrically like connect, how they connect it together. But the way I perceive it is like yin and yang. It's like you've got our observable reality, and then you have this quantum reality, and they say it must be connected through this idea of quantum gravity that is in this imperceivable extra dimension. And what this then opens the door up to is like, you know, wormholes and things like that, where you would say that like the holographic principle. So if I'm playing a video game, like if I'm playing Minecraft or something, it seems like I'm in a three-dimensional world when I'm playing the video game. But I know I'm not really. And I know really I'm on a microchip somewhere, right? And that if I were to take that microchip, I could connect it to a different microchip somewhere else. And now, you know, they would be together, but, you know, they would seem to be super far away. It's kind of like that idea. And I think that the ether then adds this extra dimension to explain, like, how can you, you know, how can you wrap something together? There must be some medium that you're in order for, like, that type of thing to happen. Does that make sense?
Yeah, so it's like a subatomic, the fabric of the subatomic reality.
Yeah, and so like molecules will like exchange energy with this ether all the time. So it's the idea that like Hal Puthoff's 1987 paper that says ground state of the hydrogen atom is, he says that, oh, this at the hydrogen atom when it's at rest, it's not radiating energy, but they would expect it to radiate energy. And they're saying, well, why doesn't it do that? Because it's spinning, right? It's got this quantum spin. And they say, well, it's because it must be in some sort of equilibrium. Like whatever energy is being radiated out must be getting absorbed in at the same exact rate. So there's this idea that like particles are actually just exchanging energy with this 0 point energy all the time. So they might have like a reservoir of energy that they're kind of like tapping into. So I think that's a way to put it.
Nassim Harriman has this concept of the Schwarzschild proton, where he had mathematically derived that every proton was two protons spinning around each other at the speed of light, putting information into the vacuum. Maybe it's the ether is what he's talking about. He calls it the vacuum of space-time. And so it's depositing information into the vacuum. The vacuum itself then is doing a massive calculation of everything in the known universe and then giving you a local response at light speed as the photon emerges from the vacuum back into reality. And so that may be how the information is being, or one way that information is being transmitted into the subsystem, into the...
Have you guys ever talked to him or had him on the show or anything
No,
like that? Or have you just kind of watched his content?
I've only seen his stuff. Yeah, people have been telling me to contact him for literally 19 years. I would love to get in touch with him.
Yeah, and I just realized we're actually live on YouTube. I accidentally went live without even realizing
cool.
it. So, okay, I guess we're just going to play this out.
Awesome. Rock and roll.
Whoops. Okay.
I should post it. Well, is there a link?
Go ahead and post if you want. I'm going to like re-edit it, probably re-upload it later on.
Okay,
I
cool.
accidentally just realized. Okay, so... Yeah, Nassim Haramein, you know, I think he's the only person who can claim the title of 0 point energy influencer more than I can probably, because he's like the OG. And one of the things too is a lot of these guys, one of the things I've realized is they use the different terminology for the same stuff. So he'll hear people use like quantum vacuum, or they'll use a vacuum, but they'll also say, well, the vacuum's not empty. You know, it's not an empty vacuum. And so it's the same idea, is that 0 point energy, the ether, they're connected through this idea of an extra dimension. And this is where I wanted to kind of take it in the next kind of discussion with you, which is that, like, the alien topic. You know, especially recently, Anna Polina Luna was on Joe Rogan, and she was talking about, you know, the extra dimensional aliens. I mean, you guys have heard this. I think you guys have either had her or Nancy Mace, or, you know, you guys have had people on
yeah, we had both. Yeah, we interviewed Luna, Anna Polina Luna, while we were at Congress. We did like a round table where different congressmen were coming in and sitting down. So she came in for about 20 minutes. And then Nancy Mace we had on officially as a guest on IRL once.
So what are your thoughts? What do you think about Congress, and what do you think about this UFO disclosure stuff?
I think that I think it's a misnomer to say extra dimensional. That's insane. You and I are extra dimensional creatures. We live in multiple dimensions. We are in the fourth dimension. We actually exist in the fifth dimension, even though you might not see it with your eyeballs. So that is like a really dumb layman thing to say, extra dimensional, that these things are extra dimensional. Yes, of course. If we're talking like spirits, I don't believe them. I don't believe that spirits are piloting airplanes. I don't.
Yeah.
I need evidence.
So this is the thing too. It's like, I love your take there. It's like extra dimensional. What does that actually mean? Like, yeah, we're extra dimensional beings. We live in 3 dimensions and a time dimension. So it seems like it's just like a red herring. They're just throwing this idea out there, or they're trying to make it sound scary or something, or like sensationalize it. Like, oh yeah, the extra dimension. Because when I found like, okay, there's this extra dimension, this ether, and maybe this explains how we can do wormholes. I'm going, well, I wouldn't call a being that goes through a wormhole an extra dimensional being. I would just say it just went through a wormhole. It's still in our universe. But granted, it could come from a different, universe if you believe in multi-worlds theory. So I guess what I would want to know from them when they're asking this stuff is like, are you saying that there's infinite universes and that you can go to different ones? Because that would be a major physics claim to say, right? Is that there are multiple universes and the aliens are coming from a different universe than we're coming from. So, I mean, what do you think? Do you think she's just doesn't understand physics and science, or do you think that like this is some kind of narrative that's being pushed?
Well, she doesn't understand what extra dimensional means. Obviously, if she's just repeating that, she's repeating what she was told by someone that probably was told that or decided that's the narrative we're going to run with. But I also think they are working with like space-time warping technology, that they're creating cavitation bubbles and defying, classical physics and things like that.
Mm-hmm. Yeah. And I mean, you just have to listen to like what science and technology advisor Michael Kratsios has been saying. If you question that, I mean, he literally said we have the ability to manipulate time and space to annihilate distance, and we've had Trump say multiple times that we've got weapons that nobody understands how they work. I mean, he said it multiple times, like it had to be scripted, basically. And people think that manipulating time and space is some magical sci-fi Star Trek type thing. But actually, it's much simpler than that. It's really just about, gravity is just mass that's condensed into a region that's pulling on something. That's the way we at least perceive it, right? It's not necessarily exactly correct. But mass is just energy. E equals mc squared. So in theory, if you have a whole bunch of energy, then you should have gravity being sucked towards that, right? I mean, that's a simple thing to understand. So then I would say, okay, well, at what scale? Like, does it have to be a sphere of mass, like this size of this sphere here? Or can it be a super, super, super tiny dot, right? Can it be a super tiny dot and I just compact as much energy onto that little tiny dot? Is it really about energy density, right? It's really about how much can you compact onto a little tiny point. And it turns out when you look at it from that perspective, it's not that insurmountable of a challenge. It turns out we can have like these super powerful lasers that focus energy onto a very tiny point in time and in space. And that, in theory, could be enough to stimulate a gravitational effect that can be, measured. And then that can also be useful for things like fusion as well. So I don't think it should surprise anybody that they're at least working on the ideas of anti-gravity or gravity manipulation, space-time manipulation, whatever you want to call it. It's all the same thing. I would just call it like manipulation of the ether. You were talking about cymatics. Like, the question is, how do you manipulate entanglement? How do you create entanglement?
I think you need to understand where you're going. So what you do is you have to map the matrix. You get a 3-dimensional space, and then you derive what is in each position, how the consistency, how much of it, and where. So what, how much, and where. If you can match that for every incremental point in this 3-dimensional XYZ cube, then you've mapped the matrix. You know what, where, and how much of each in each space. Then you have a mathematical map you can teleport to. So if you know where you're going, if you know what you're going, where you're going, what you're going, it's the same thing. What, where, it's all one thing. What is it? That is where it is. If you know that and you can calculate that, then you can target it, I think, and then you can replicate it locally and be there at a distance.
You know, they have a term for what you just said. It's called solving Schrodinger's equation. So actually, there are people working on this idea of like, if there is a medium, and even though we can't perceive it, is there a way where we can like reverse engineer, like you said, like figure out the matrix, right? Like we only see this flat surface. Is there a way to figure out like what is all of this, like what this whole bulk here that we can't see? Is there a way to measure it and measure its effect on our flat 2D reality? And the answer is yes. The Ehrenhoff-Bohm effect is a good example of this. Ehrenhoff-Bohm effect is a real experiment. They take a solenoid that traps all the electromagnetic fields in a cylinder inside of it, and you would say, okay, well, there's no electromagnetic field signal on the outside of the solenoid. So if I shoot an electron past it, there shouldn't be any interference or any, shift in the phase pattern. But there is. There's an actual measurable effect. It's called the scalar potential. And so, or the magnetic scalar potential. And so the question here then is, if you can measure this, then can you reverse engineer it? There was a great presentation that I was watching about or optical vortices of light. And really what it was about was like trying to figure out, like, if you have this vortex motion, if you were looking at a two-dimensional surface and you just saw a circle, could you map out what the vortex motion is in an extra dimension? Could you map it out? And after they model it out a while, they come up with, and they say, oh, here's an equation that, seems like it fits what the experimental data shows. And so from that kind of, answers the question to, could you actually create entanglement? Could you manipulate the ether or this extra dimension to cause two things to be, joined together now?
Maybe.
Well, yes, if you can solve it. Go ahead.
If we can figure out the subatomic formation of the matter and then figure out what frequencies, if this theory that it's a cymatic, phenomenon that's causing subatomic formation, if you can figure out what frequencies cause the subatomic formation to cause the matter to be what is thus, like this area that you want to entangle to, then it would be more of creating the frequency patterns in a system to reproduce the subatomic features.
Yeah, I think that actually is what it is. So, because cymatics, if people are not familiar, the simplest explanation of cymatics is you just take a metal plate and you put sand on it, and then you just hit it with vibrate the plate at different frequencies, and different shapes begin to form. So the question here is this connected to this idea of the ether? Like, why are those shapes forming from certain frequencies? Is it because we're in a medium and you're seeing this vibration, and can you then map that? That's what they are doing with Bose-Einstein condensates. That's actually what Bose-Einstein condensates are. Now, we think of them at this thing at a very low temperature, but it really, when you boil it down to what does it actually mean, is this coherent shape that's being created by a frequency. And so it's like, how is that being created? Go ahead.
And like the cymatics on the plate you were talking about, that's a two-dimensional representation. When you see three-dimensional bubble cymatics, good Lord, I think that is that Bose-Einstein condensates? They think that they're bubble cymatic, or maybe something
similar? We got to be getting close. I mean, I think we're blurring the line at this point in terms of, is it the same physics at play in the bubble cymatics as what we see in the Bose-Einstein condensates? I think so. And the idea there is that we're creating these coherent, stabilized shapes. And the other thing that the ether then opens up the idea to is like just stabilized structures in general, in geometry, stabilized geometric structures. So a good example of one would be like a smoke ring. A smoke ring, like when you blow a smoke ring, it's crazy how stable it is. Like that thing can blow and blow and blow. And the reason why it's stable is because it's a toroid. It's a toroidal shape. So you'll have the toroidal field, and then you'll have the poloidal field going around the toroidal field as well. So you'll see the smoke kind of going around the ring as well as it blows. This also holds true for plasma as well. So the question then is, can we manufacture reality through these concepts? Or, going back to the disclosure question, can aliens do it? Can we make a Star Trek replicator out of this? When you start to be able to say, okay, I'm going to stimulate the ether with some, frequency, and then I'm going to cause an effect to happen, a coherent shape to happen. Now it's just like, okay, I'm just going to tune it to whatever I want to occur, right?
And it would be about the impulse of it too. So about the frequency and how fast you're introducing the frequency into the system. So like at a certain frequency, and then you like slow it down. Maybe you won't hit it, but then you there's these, what impulse are you delivering and what frequencies are being delivered, and then you'll be able to produce hydrogen. with that impulse frequency. And then if you do that and add other impulse frequencies to produce heat or magnetic confinement, you might be able to produce fusion.
Yeah, so the hydrogen thing is really interesting because I keep thinking of this one experiment, the dynamic Casimir effect, where real photons are just being pulled out of the virtual photons. Because when I think about that from the perspective of, the ether 0.8, I'm going, wait, we're just pulling light out of the vacuum, out of nothing, right? Well, how is that happening at all? And if we can pull light out of the vacuum, then, well, E equals mc squared. So light is, energy is matter. So, and the most simple element is hydrogen. So can we just literally produce hydrogen out of nowhere? I think the answer is yes. I think we actually can produce hydrogen out of nowhere and then transmute elements as well. The fusion aspect of it, I think, is a little bit more complicated. I've been doing a pretty deep dive into fusion. And I don't think the secret is just like understanding gravity or what have you. It's a little bit more complicated than that. I think the real secret of fusion is actually non-ignition fusion. Like in our heads, we think of it as like we need to make a star, and we need it to be this star that's roiling with heat coming out of it. But if you incorporate the ideas of like Nikola Tesla and like electric circuits that are super efficient, then you can actually make an electric circuit, electric generator using fusion that doesn't require ignition, that can produce over unity. So the idea being we can get small scale fusion reactions, like temporary ones, like pulsed ones like you're talking about, and get fusion reactions to occur, but we're not going to get this permanent sun that's there. And the output of that can be higher than the total energy input, which is really what we're trying to achieve, which is just infinite free energy, right?
In order to build these little suns, I was thinking, I think I know how to do it. There's this guy, John Kansas. He was a chemist in Ohio. He passed away in like 2008. He was looking for a cure for cancer, and he was running frequency through salt water in his laboratory, different frequencies. And I don't know if you've seen this. There's video of this guy doing this. He finds the frequency. I don't have it written down. He runs a certain frequency through salt water. It lights off fire like a hydrogen flame, 1600 degree hydrogen flame off the surface of the salt water. There's a gap between the salt water and the flame, just like the sun. Between the surface of the sun and the corona, there's that gap. And I'm like, okay, that's an electromagnetic flame being produced. So if that salt water was in orbit, it would coagulate into a sphere naturally. We run the frequency through it. You get a light bulb, a star. And so you figure out if you can collect that heat somehow and use that heat to produce the electricity to continue the frequency, you'll have an ever-producing star, basically. But I wonder if that would produce like a Z-pinch phenomenon, if it would cause some sort of electric discharge into our own sun, into the Earth's magnetic field. Like, it could be a real dangerous experiment, but it would be an immense amount of heat. And you just have to fuel it with salt water. You just have to keep pumping salt water in.
Yeah, and that's the thing, is that once we realize that we can use like water as a fuel source, I think it was Redheaded Libertarian was posting about Stanley Meyer the other day, and I thought at once upon a time that the whole water powered car thing was nonsense, but then I realized I watched this video about if you take water and put it in like a cup or a bucket, and then take a tube and go up like a couple hundred feet and just in altitude, like, up some stairs or whatever. And you have your water tube and you suck the water all the way up through the tube. You get to a point eventually where above a certain level, the water boils. Room temperature just boils. So like the water will go up to this level. Everything above it just turns into gas automatically. Because why? The pressure. There's not enough pressure. So without enough pressure, the water can't stay together and the water just falls apart. And so this would be how are people able to make a water power car? Well, that's how. You basically cause the hydrogen and the oxygen to just fall apart. And now you can use either as the fuel source. You can pump the oxygen, I think it is, to your engine if you want to make it more efficient. You can potentially use the hydrogen directly as fuel source as well. So we have fuel all around us if we understand nuclear physics and nuclear science. And if we can manipulate gravity, if you can manipulate gravity itself, in my mind, you should be able to cause that net pressure, that lack of pressure, you should be able to cause that to occur. And then the question is, okay, well, how do you make a system? It's actually pretty simple. You just have your area where you have the water comes apart, and then you send it to a different area. You either send the hydrogen or the oxygen where you want to go to produce energy, or if you want it to recombine, you just send it to a different area where now it wants to come back together. It's just going to recombine there, and then you can use the excess energy or the energy that's produced from fusion. So I think the idea of the water powered car is definitely within reason. And I think that some of these like low energy nuclear fusion reactors, they're trying to do what you just mentioned, which is like, burn salt water, or in some cases they're using the air. Air is fuel as well, because air's got potentially enough elements in it. They don't need a lot of molecules in order to make, fusion reactions occur.
Oh man, you're as you were saying about like making water, reducing the density so it becomes gaseous. I realized, okay, so if I took my salt water out into orbit to light it up like a light bulb, it would turn into gas. So maybe we need to take ice. We need to take ice into orbit and just electrocute ice, or run a current through ice to give off maybe, and then it would melt and create like like the sun. The sun doesn't just evaporate; it's keeping itself in position. So at some point, I feel like the heat would make a self-containing. I don't know.
So let's talk about fusion, because this was the thing that, man, what an eye-opener for me. I was really all of like, why have we been failing at fusion for 70 years? Supposedly we've had the H-bomb since the 60s. But I don't think there's ever been an official use of the H-bomb. And nobody really knows what a fusion bomb is. We just assume it's this big boom, right? We just assume that it is. So when I started researching fusion, trying to figure out, like, okay, why we failed? Why does it suck? First thing I found is that the hot fusion people have really a one-track mindset. They're trying to get to ignition. They're trying to get to a star, producing a star that is really hot. Now, here's the problem, is that the energy efficiency of any system where we're just getting heat out of it is really low. Like, I'm just going to throw a random number. This is just an index number, like 20 or 30%, let's say. If we could produce electricity directly from our nuclear reactions, that efficiency can get up to like 90%. So 2-3 times more efficient than those other forms. So in theory, we don't even really want all this excess heat. In a perfect world, what we'd like our power plant to produce electricity directly, not like making steam and then having steam spin the turbine or whatever it is. So when I was looking in the fusion types, I found one that I've called, I can't say I coined it, but I'm calling it cool fusion. So cold fusion was this idea that you could put like metal rods in water and then all of a sudden put like a current through it. And now it's going to boil and there's going to be this excess heat in there. And this was considered like basically like room temperature nuclear reactions. Hot fusion is like a tokamak. We're saying, okay, we're trying to get ignition. And once we get ignition, then ignition happens. And now there's enough energy that we've got this runaway star that runs itself. There's a third option, cool fusion. And this is the one I was kind of saying before. So the companies that are doing cool fusion are Helion Energy, which is funded by Mithril Capital, Peter Thiel and Sam Altman. And another one is Tri-Alpha Energy. And both of these have backing by the Department of Energy. And what they're doing is they're saying we're not even trying to get to ignition at all. They're keeping their temperatures lower than that, but they're using a different fuel source. They're using helium-3. So they're doing something where they call it aneutronic. The neutrons are where the heat comes from. So why is all this heat coming out? Well, the neutrons. So they found a form of fusion that they're doing where they call it aneutronic fusion, where there's only a very, very little bit of neutrons coming out. And so what this means is they can actually capture the energy as electricity directly. The way they explain this is they say, well, okay, we make this plasmoid, and they're literally creating a plasmoid, like a plasma smoke ring. And they create this plasmoid, and its magnetic field strength is so strong that while it's trying to spread out and come apart, the magnetic field strength keeps it together. And the magnetic field strength pulling it together while it's trying to expand, like this is where they pull the kinetic energy out of and turn it into like an engine like this. At least that's how it's described.
You know what I think that is friction. That's that excess heat that's in that system, or something like friction. I asked ChatGPT to help me calculate this because what's happened, there's this ideal gas law. It's that the pressure of a system is equal to the volume multiplied by the temperature. I think that's what it is. So there's an inverse relationship between pressure, volume, and temperature of a system. If you increase the pressure, the system's either going to expand in volume or it's going to get hotter. And that's basically the thing. But the ideal gas law is written for tubes to go longer and shorter, to get water out of wells. It was written in the 1800s. So fusion, I think, is this gas, this plasma, the fluid. But it's expanding spherically. And when it happens, it's expanding so fast that the expansion itself produces friction. And that friction is brought from without the system. It's outside of the system, comes into the fusive system. The friction then makes it get hotter faster, which makes it expand even faster, which adds more friction, which makes it hotter faster. So you get this runaway expansion. It may not be as simple as just saying it's friction, but I think that might be the phenomenon of why.
I think that's the idea, right? Is that you're taking this kinetic energy and you're able to then convert this to electric energy. The way they describe it, like the CEO of helium fusion would describe it, he says this high beta values, this high magnetic field compression. I think he says like biotic. I forget how you say it, compression. And I guess this is the part where people like struggle with this concept because it's so different than what we've been led to believe from the public perspective of like, oh, we're trying to make this star, right? And the benefit of his approach is they use a pulsed approach as well. So they minimize the total input energy. So instead of like trying to like focus this huge amount of energy to make ignition happen, they're like, nah, we're just going to hit it with this small pulse, and then we're going to try to recuperate as much of the energy pulse as we can as well. Just like with an electric car, with like how the braking in the electric car like recuperates the energy, same kind of concept. And so I just, even if I didn't believe that they were on the right track, I would still be like supportive of what they're doing because they're thinking outside the box about the problem. They're going, hey, it's not really just a matter of trying to get to ignition. What if we make our system super efficient? Because once we get to a point where we're getting more energy out of this fusion system than we're putting into it, then we just have to scale it up, right? Because then you have infinite energy. Once you get to over unity, you're good. It doesn't matter if you have ignition or not, right?
Yeah, when you're talking about getting a system started with like just impulses, I think of that when I'm lighting my incense with a lighter. You can click the lighter and have the flame there and just hold the stick and just run all that fire, and you're going to get that stick lit eventually. Or you can burst it and just tap it with flame, and it'll get really, really hot really fast, and you let go, and you can use like a third or a fifth of the fuel to get it lit. It's just about efficiency of fuel, efficiency of input heat. You don't need to lather your system with excessive amounts of heat to get it hot. You can pulse it.
And that's what Tim Pool was saying, actually. He said, I'll probably never forget that. He said, free energy is about efficiency, right? If we could get energy, if we could have energy that's even just 10 times less or more efficient, less expensive than what we have right now, it would change everything. Dude, everything about the world. That's what free energy is really about. Everybody thinks of it as like free energy is like energy is going to cost zero, but it's not even about that. And it's also not about producing something that, produces energy from nothing at all. It's about efficiency. It's about getting a system, designing any system, this square system, that you're getting more out of it than what you're putting into it. If you've done that, boom.
And can people even get access to it? That's another aspect of, is that energy free? Because if someone in a laboratory has unlimited electricity but no one else can use it, it's not really free energy. Freedom really means like, can people use it? Is it accessible to people? Is it efficient in that it is easily utilized by the populace?
And that's what I wanted to ask you next, which is, do you think they'll ever let us have this? Because, just long story short, I dug into it. They're definitely hiding fusion. And it's kind of silly when you think about it, because you go, we've had the fusion bomb since the 60s, but we can't figure fusion out. Like, what am I missing here? The 60s was like a long time ago. So they figured the fusion bomb out, but they just couldn't figure out how to get energy from it. So the question is, are they going to give it to us, and why or why not?
I think every time we hang out, we talk about this, and we keep asking each other this question, because it's like, I think I want you to be like, oh yeah, everyone's going to be. I don't know, dude. It's dangerous. Obviously, this is where I come to is how explosive is the potential force? Like, what if some idiot monkey drops it on the ground? Are we all going to die? Because if that's the case, you can't give it to every idiot monkey. No offense to the monkeys out there. The hominid species is descended from apes, according to genealogy records. And people make accidents, and they sometimes fall down or mess up or get angry and do stupid shit. So I'm not totally against not giving every piece of information to everyone. I'm okay with that. I don't know if fusion's necessarily the answer to thriving as a species, but I do believe energy efficiency is. I'm more interested in hydrogen, which I'd like to talk about too, but where's your mind at?
So what do you think then, where's the line? Right? Where's the line between national security then and the public good, right? I mean, if you can make the justification that, well, sorry guys, can't have fusion because you can make bombs that can annihilate the planet, and I think you could. In fact, I think that's probably what's going to happen. That's just my personal opinion, but where do you draw the line then in a scenario like that? And I think that does, or maybe I'd ask you, does that explain the whole situation that we have with the UFO phenomenon right now? Like, why is this whole thing such a huge mess? Is it because whatever it is that they're hiding is so dangerous that like there's a serious moral question over whether or not it can be allowed to be given to the public?
That may be. Like, if they have fusion generators on those things, I don't think they do, because if one of them gets knocked down, that would be like the cat is out of the bag. It's such a risk to put one on board. But if they're not on board, how would they be powering it? Like by laser from a base station and moving it around like a magnet or something?
Could be. Could be. I mean, that is, Bob Greenyer literally thinks that. Yeah, like with the orbs in the MH370 video, he thinks they're using like satellites and shooting lasers to create like interferometry to shoot them around. Now, I think they are on board. And in fact, I would say, I think some of that has happened before. I don't think like they've shot down like a plasma ball and then they were like, oh, we got this plasma ball. But like there's a drone called the RQ-170. I don't know if you ever heard of that, but during 2011, under Obama, Iran hacked this drone, and they claim they hacked it. The Obama administration denied it, and then they like posted pictures of it. You're like, oh, well, that's definitely the RQ-170 drone. And then they made their own version of it. And I kind of wonder, looking at it, I was reading into it the other day, like everything about it's classified. So we don't even really know exactly what propulsion. Like they suspect there's a certain kind of engine they were using. But what I found is that these fusion engines, they kind of use a Z-pinch type mechanism. They call it dense plasma focus, but it's like a Z-pinch mechanism. All they've done is they turn that the turbine, the engine, they just remove the turbine from the engine, and they turn this into like a tube that's a heat exchange. So you put these magnets along the edges of it. They're like opposite polarity. And then this could just cause like any electron that goes through it or plasma that goes through it like slows down. And I think they use like a helical motion. So it creates the plasmoid in the middle of it. And then the plasmoid creates the jets that come out of it, just like if you were looking at a neutron star. And they just angle it so those jets are the propulsion. Like that's how you fly around. So if you shot that down, like you could figure out the science behind it, but I don't know if you're going to figure out like fusion immediately. It's a slightly different concept.
It sounds like rifling, like the way that they carved the spherical or the spiral into the engine to create either accuracy, essentially plasmoidal accuracy trajectory, and very similar to how they built rifles.
Did you know that when they some of the plasma fusion, nuclear fusion scientists, like there's a couple of shapes that keep coming up. Toroids are one of them, but helical motion is another one that comes up all the time as well, like this vortex motion. So it wouldn't surprise me at all if there is literally a connection with like guns and the helix motion of like the bullets and things like that as well. Mm-hmm.
You know where I'm at now is the hydrogen revolution that it sounds like is like right around the corner for the last 50 years. Out of Rice University, they're doing this graphene study. I talked with Jim Tour, who's like one of the head scientists down there working on it, and they figured out this process called flash joule heating, where they'll electrocute carbon, any kind of carbon, trash, plastic, dirt, whatever. They put it in a vacuum and they electrocute it with 7,000 degree pulses of electricity, and it breaks it apart, and then it cools down and reforms into its most stable form, which is the hexagon, which is the graphene structure. And so you get this black powder graphene, bulk graphene, and it gives off hydrogen byproduct. And so for every kilogram of hydrogen that's released, you get about $4.50 worth of graphene. So they've inverted the cost. It used to cost money to produce hydrogen. Now you receive product to produce the hydrogen. So after the cost of electricity induction, you get $4.50 in return for every kilogram of fuel, hydrogen fuel you've produced. And he's saying our methane system across the United States is ready to introduce the hydrogen for cars, for fuel. So if we want to start fueling our car, it sounds like they have contracts with the Department of Defense, he said, that we're on the cusp of a hydrogen revolution fuel-wise. I could see like a hybrid petroleum hydrogen cars where you can pump one or the other. I don't know if...
I think that my sources have told me that there's companies that were already in the hydrogen game producing hydrogen. I didn't hear exactly how they were doing it, but once you open the door to solving fusion, and just what we've already spoken to, like cymatics, understanding the ether, if you can create coherent shapes, now you can do alchemy. Now you can produce any element that you potentially want, and you can potentially do it at very low energy costs.
Fusion.
Well, also, the last thing I was going to say is that part of low energy nuclear reactions, I did this interview with ENG8, low energy fusion company. And one of the claims they made was that they could potentially produce hydrogen at a much lower energy cost than what the conventional approach would be to it, too. So you kind of have to keep your eyes open on some of these companies. Like, if you were to look at it, they may just look like a completely conventional company, but they might then be using some of these electromagnetic physics type concepts to really be making more money than what you would be possible otherwise.
When I think about fusion, I think of the big ask that it's like, all right, this is okay. I'm from 1979. I'm cynical. That's just the way it was growing up in Ohio in the 80s. Our team, Cleveland Browns, always lost. It never worked out. I had to break out of that mindset, but I'm like, that's what it feels like with fusion. It's like we're never going to get. I don't want to say it. I don't even want to joke about it because I don't want to manifest that it's happening. Obviously, we're getting fusion. People are fusing things. But do you think it's actually reasonably going to be like a power source in the next 30 years for the common man?
Yeah, I mean it exists. I'll tell you that much. Are they going to give it to us? That's the bigger question. And I think that they are weighing exactly what you just said, which is they're weighing the question of what's the risk of somebody using this and creating a weapon that wipes us all out, and can we stop it if they do, and do we have the deterrence in place to do it? But absolutely, I think not only are we going to get fusion, I think it's going to get a lot weirder than that. Is that one of the first things that's probably going to happen is we're going to have to start coming up with new names for some of these energy sources. Maybe the hydrogen revolution sounds like a good way. Maybe we'll just call it that, honestly, because I think it's going to be more all-encompassing. We're going to see like fusion companies like Helion that aren't even doing ignition, that are producing excess energy. And people are going to be sitting there wondering how. I mean, I was watching a debunker person who's like a nuclear physicist themselves, and they were like listening to the CEO of Helion Fusion. They're wondering how all these claims can be possible when these people are struggling to make a tokamak reactor, But then you're also going to see stuff like free energy microchips at the same time. Like our low power devices, everything up to like a cell phone, in the next 5 or 10 years, like they're going to be rolling out free energy microchips. Like these devices just aren't going to be running out of energy anymore. And people are going to be like, how is that possible? And they're going to come up with they're going to call it like I've been joking, they're going to call it like space juice. They're going to come up with some stupid like made up name. They're going to call it's just harnessing space juice. Don't ask questions, right? Like, and we'll be like, yeah, okay.
It'll be like
space juice.
Tapping into the piezoelectric vibration of the ether or something.
It's got to sound something like really technical, and then that's what they'll say. And then everyone will just be like, I don't question why my phone never has to run out of energy anymore,
Subatomic piezoelectrics is a fascinating concept. I mean, just piezoelectric in general, that you can use like intensive vibration to get an electrical charge. And then if you can scale that down to the microchip level, the chips themselves power just by atmospheric, indenture, create their own conductivity.
There's probably like at least 3 different ways to do free energy from the micro scale that I've found. One is using the Casimir effect, which Sonny White has been doing, and I think Garrett Modell out of the University of Colorado. Paul Thibodeau is using like a thermal effect. Like the thermal changes, there's vibrations. And even it can be in a stationary temperature, but just the thermal just vibrations, Brownian motion. He made a microchip that basically just harnesses that as well. So in addition to what you just mentioned, so there could be multiple different ways. Like the piezoelectric thing, people, anytime you have like a PhD physicist come on, especially if you're talking to them like on Tim Pool on a big show, you should always ask them, what is electricity? Where does electricity come from? Because piezoelectricity explains it. Like for people who are not familiar, piezoelectricity is like a quartz crystal. You can squeeze the crystal and it'll produce electricity. They use these in watches, low energy devices, right? Because you can just shake your watch and now you get electricity. The reason why that happens is when you squeeze the crystal, the positive and the minus charges in the lattice structure of the crystal separate. Normally they're in an equilibrium. The positive and minuses, imagine them being next to each other. When you squeeze the crystal, it pushes them apart a little bit. So what is electricity? Well, electricity is just the positive and minus charges being separated, just like with the piezoelectricity. So anybody that understands electricity should be able to tell you at a basic level, all electricity is positive and minus charge separated.
Is it?
And we can go ahead.
Is it because when you separate the positive and minus charge, they want to come back together, so it produces an electrical current between them?
Bingo. You nailed it, right? So now you can see like, oh, if I just look at it like that, then it's a completely different view of what electricity even is. Electricity is like a breaking of a symmetry, right? It's like, oh, we're stuck in this symmetry. Oh, if I just rip these things apart, oh, now electricity exists. Like, oh, and we should be getting taught electricity like that. That's a much more logical, intuitive way than like, oh, the power plant is like producing this electricity and then shooting it through the wires, and then it's like coming into my house at the speed of light, which is not how it actually works. It just seems like how it works.
Dude, I want to capture lightning. I think that we've been staring at it the whole time. If we can produce tethers that can, like graphene tethers or some sort of metamaterial that can absorb, that can conduct the heat into a base station and then absorb it down at the station. Like you could have these like feathery tethers up in the atmosphere constantly pulling the static charge, so you'll never actually have lightning strikes anymore. Like you'll prevent them and you'll just be absorbing the current. And then it's just about having a battery that can capacitate it.
I think it's even easier than that. It's like, where's the electricity from the lightning strikes even coming from? Right?
Deep space. If you see those above, if you ever watch above the clouds, those sprites they call them, that go just God knows where out into the next realm of galaxy or whatever.
And I'm not like, I like the electric universe theory. I think there's some problems with it, but that was one of the fun things that I learned from, is that I like hearing other people's point of views, because then you hear like, what do the electric universe people say about like the standard model and their view. And one of the big ones they go is like, where's all this energy for all these lightning strikes coming from? Like, we're us on this planet in equilibrium. Well, those are a huge amount of energy coming from. And so, of course, they claim it's coming from the electric currents that are connecting the Earth and the Sun and all the other planets in the solar system, which I think actually makes a lot of sense. But then the point is, whatever electricity is, whatever is causing those lightning strikes to happen, we should be able to tap into that. We should be able to harness that. I mean, my view is that if energy is mass and we can do stuff like the dynamic Casimir effect and just pull light out of the vacuum, then that means energy's everywhere. That means we don't even need the sun, and we don't even need to make a sun. We can just pull energy theoretically just straight out of the vacuum, anywhere,
so you're talking
we're at.
Dynamic Casimir effect, you're talking about, is it light appearing out of the vacuum? Is that what that is? So that's sort of like sonoluminescence, where if you create a bubble underwater with a certain vibration, you'll create light. And I think maybe what's happening is that the Higgs field, there's a vibration in the Higgs field, and that if it hits a certain frequency, it cracks and produces photons. And then they basically, it's like the photon is coming through the Higgs field. This is an old idea I had 15 years ago. I don't know if it's actually real or not. And then that cools down. Those photons can cool down into matter. But I don't. That was just a rough kind of a
sure. I mean, the Higgs field is really like 0-point energy, but like with tricycle wheels attached to it. You know, it's like they're like the Higgs field explains like 1% of mass. You're like, but that doesn't really explain like anything, then, does it? But it is the idea that there are these fields that we live in this structured this construct. You know, and so that would be open the door to 0-point energy and open the door to this space-time flexible solid that can be manipulated. Go ahead.
If like you're saying, electricity is produced when you pull apart a positive and a negative node, and it's trying to find itself, it's trying to come back together, so it has this current pulling. Then a lightning maybe is that, and so the Earth's core would be like the positive or the negative charge, but it's both. I think it's both positive and negative. It's an interesting. It's
a capacitor, right? And remember when Dr. Yu was saying, when we were explaining why is gravity and electricity so, like, why are the strengths so different? And Dr. Yu took his magnets, and he took a string of magnets, and the string of magnets would pick up the balls, right? But once you start folding the magnets over, you're equalizing the charges. And what's happening now is that now all of a sudden the magnet can't pick up any balls anymore because it got so much weaker. So the Earth is also a magnet. And so why are we seeing the electricity, strike down from the sky to the Earth? Is that you're seeing this potential difference. And as that potential difference builds up, eventually it gets so strong that zap, the minus and the positive decide that it can break through the insulator. What's the insulator? The insulator is the air. The air is the insulator in this case. Air is actually an insulator. We have to remember that even the air is a medium. So that's why we don't see electric strikes. That's why we do see the electric strikes. And here's another one for you. The lightning is a plasma. Because what is a plasma? All a plasma is a positive charge and a negative charge separated, ripping the electron off the atom, leaving behind a positively charged ion and a negatively charged electron. So when you separate these out, are we just creating electricity directly when we do that? And this is why I always thought, like, the whole idea of fusion using plasma, like, it should be direct energy conversion, because literally electricity is just a separation of positive and minus charge. Now, here's one of these things I'll leave you with on this is that the electric universe theory, one of their big questions is, why is there a plasma corona around the sun? Shouldn't plasma, if its positive and negative charges separated, shouldn't it try to come back together and equalize? But if that was the case, then we shouldn't see this corona around the sun at all. There shouldn't be a difference of positive and negative charges being separated from one another. So clearly, I think there must be something else going on.
I think it's that similar thing with what John Kansas learned in his experimentations in the lab, is that there's a frequency running through the sun that's lighting it up. It's causing it to give off the flame. That's what the corona is. It's exactly like his experiment. If you watch that video, John Kansas, it's Kansus. It's like a 2007 video of him running he tells you what frequency it is too. Run it through salt water, get that hydrogen flame. That's my guess.
Interesting.
So that would lead me to believe that the sun then has the chemicals that make up salt water. Obviously, there's hydrogen in there. There's sodium in there. There's a lot of chemicals in the sun. But
Yeah, and the sun itself, maybe it just reaches a certain critical mass. And then, I think that the standard theory holds, right? You just have this huge amount of mass, and then you have this critical event happen, and yes, then we get ignition to occur. And then what's happening inside the sun, there's actually a lot of theories about that could be something related to vibration. Planck's constant is like what we imagine is like the smallest possible vibrational scale that's out there. That could be a cutoff point. That's where they use as the cutoff point for calculating the 0-point energy, actually. So there could be a connection to that. The other idea is that maybe the sun is like a lattice structure. Like maybe it's more like a solid. Like when you get inside of it, maybe everything's so compact that it's almost like a crystal structure. And so then what could be happening would be more like piezoelectricity, where like maybe you have like this vibrational like lattice structure inside the sun in the middle of it, which I think is a cool idea.
That would make sense as to why a frequency would cause some sort of disruption like that. I think that's the right word. I like the way it sounded.
Yeah, because it's a resonance effect, right? It'd be like, if you hit it with a frequency, then you're going to see some type of counter resonance effect, just like the photoelectric effect, which was like when we shot light at a metal, we did not see a significant difference when we increased the brightness of the light, but we saw a difference when we increased the wavelength, when we changed the color of the light that hits it. So it goes to show, resonance effects are what really seems to explain the universe.
I think that comes from how photons interfere with surface plasmon. They seem to refract off of the surface plasmon at the center of every plasma cloud and transfer information. So I think that's how light transfers information to plasma. And if you look deeply into surface plasmon and the way that it changes the red and the blue shift of the plasma fields, depending on how the light is interfering with it.
So the plasma front, let's see, is there anything else I want to touch on that front? The other thing I was going to touch on is the dense plasma focus paper that I discussed, I think, on the podcast that we did together, which was finding out that they were taking these plasmas and they were trying to turn them into drones or, trying to turn it into a propulsion concept, very clearly in the papers. And so plasmoids have another name. They're called field reverse configuration, FRC. This is actually what they're called by helium fusion, as well as TAE. They came up with a new name for them, which are apparently just toroidal plasmas that are being shot together at one another. These FRCs, they have a distinct characteristic. They have a spheromac shape, so they're shaped like a plasma sphere, but they also have axial jets that shoot out of them because they're creating that plasmoid in the center. They have these axial jets. So at some point, the Air Force, and I don't know who the first person was to think about it, but I'm pretty sure it's this guy, Frank Mead. They were like, if there's these axial jets, we can use this as propulsion. And then we can have now some type of thing that's flying around. I think that the thing that really took off was when they were able to turn it into a drone. When you're like, okay, now like having a plasma propulsion is one thing. Great, you got plasma flying everywhere, but that doesn't sound very safe. I wouldn't want to be on a fusion reactor, flying around. But once you turn into a drone, now you have no problem. And now no human needs to be near it anymore. So this is where I personally, my view, I'm curious about your opinion, that I think they figured out these plasma drones and they've been flying them around for, 10, 20 years, maybe longer, who knows. And that's where I don't know how far back it goes. And people are seeing them in the sky. And they're going, okay, there's a light in the sky flying around. Basically, anybody that sees that's going to think it's an alien, right? And now they're going, UFO, alien. And then this seems to coincide in the last, let's say, 10 years with this like emergence of balls of energy, balls of light that everybody's talking about. Even Lou Elizondo wrote in his book about 3 balls of energy and 3 balls of light. So my opinion is that the governments figured this out. I don't know. Maybe they figured it out from aliens. Maybe they didn't. Not sure. What do you think about the idea that like humans could have figured this technology out? This is like the biggest point of contention in the UFO community right now is like, could humans have figured this technology out? Could we have reverse engineered it? Or does it have to be aliens because, we can't understand this alien physics?
Human. All human. If we can figure out electricity, we can figure out anything, dude. Anything. This is warping shit. I think a lot of it is talking plasma, which is a term they gave to this idea that you can triangulate or hit a point in time, into space-time. It's funny, a point in time where you'll hit it with a bunch of like lasers or something. It creates a ball of plasma. And then you move that around like a laser pointer, and then it flies, and then how does it move so fast? And it's like, well, it's because it's an illusion that we're creating. It's a ball of plasma. But then now you're talking about plasma drones. I don't know. I'm just thinking of actual autonomous balls of plasma that are using their own jets to maneuver, that are being maybe given information from the base station. But how would they be being produced? Either an onboard fusion. Then you're talking, do they have onboard power, or are they being created by this talking fusion, talking plasma phenomenon?
I remember like a year and a half ago, I was thinking that they were creating them the same way that you just mentioned with the talking plasma, which I read, which is honestly amazing. The talking plasma thing they can do, I mean, the fact they can get it to literally talk to you means they can modulate the frequency and the standing wave of it to like at will, like constantly. It's a very impressive thing. And if they can do that, then in my mind, they can make their plasma ball like whatever size they want and need it to be. And it wouldn't take that much onboard fuel to make it happen. I think that, though, that what like the plasma drone would look like would probably be like a tube with a bunch of stuff hooked up to it. And then once you like shoot it, and then it just spins up. And once it spins up, it's a plasma ball now. And it just looks like a plasma ball until it's turned off. And but a lot of people believe that these orbs can be like shot out of like a cannon. Like you shoot a plasma like a plasma sphere out of a cannon, and now it's just like a self-contained structure, and it's self-contained until it dissipates, which it's stabilized, so it won't dissipate, or it has like a very long lifespan. And so this would be the idea of like the ether and cymatics, where like you've created this geometric shape where it's like a perfect geometric shape that just doesn't lose any energy and is able to keep its form. I kind of struggle with that because, like, especially in like the MH370 videos, these things are clearly moving with some intelligent control. It's not just, oh, shoot it over that way, right? It's like homing in on things and locking in. But I don't know. What do you think?
Well, you were talking about shooting a plasma drone, as that would be your bullet, would be the drone itself. I'm thinking of like a coil, just like the rifling we were talking about. Maybe it would be a series of rings, but it would give that forward momentum of spin that would allow for some sort of energy propagation that could maybe blow it up like a plasma balloon for the excerpt for the journey that it has to go to until it either dissipates or hits its target. Maybe the idea that the idea that you would use that as the bullet itself and not the gun is pretty cool.
Yeah, and that's something I had never really thought of. But you've got these plasma bullets, and now you might be able to use them for multi things as well. I mean, they probably originated as, like you said, like spoofing mechanisms, right? Because some of these pilots, when they see these UFOs, they don't see them on radar, but then they'll see them like briefly show up. And this is, I think, where some of this idea of, is this spoofing mechanism? Well, the plasma actually will reflect radar. But if you were to change the wavelength of the plasma for a brief second, it may show up. So it could look like it's like a ghost out there. But then you can turn it, like plasma itself is a physical phenomenon. It's not just an illusion, right? It's not necessarily just a hologram. So if you can turn it into that, now you've turned it into a weapon, because once again, what is electricity? Electricity is just a separation of positive and minus charge. So if you can control that, if you can spin that up into a ball of plasma that can shoot around, now you've got a literally lightning ball. Like you're Zeus now, like shooting lightning balls down on people.
if it's just like what we're talking about, electricity, you're pulling apart the positive and the negative. So gas, either you're heating it up, or you're destroying, you're removing the pressure, so the gas expands faster. It'll be easier to get it hotter. It'll be easier to pull the proton and the electron away from it because it's less pressure. or getting it hotter. So if you can, within like the bullet of this plasma torsion, if you can reduce the pressure or enhance the temperature, you might be able to produce an electrical charge that way.
And you know what the thing was that took off? It was the lasers is what allowed this to all take off. When you even look at Helium's field reverse configuration reactor, they shoot these plasmoids at each other, these smoke rings of plasma, and then they shoot these like neutral laser beam injectors. And the thing that allowed this to all take off was that they got these lasers to be super powerful. This chirped pulse amplification, Nobel Prize 2017. That's where they found these. They were able to come up with these attosecond lasers, because the smaller the time frame that you fit the energy into, the more the energy density goes up. It's not just the region and the space that you want small, but the time region, the time of the laser gets smaller, the pulse gets smaller, the energy density goes up, and that's how they're able to get these plasmas to reach these super high temperatures supposedly. So it wouldn't surprise me if like the military had this laser technology that allowed plasma and all this stuff to happen, and then of course they just classified it because it's all weapons related nukes.
I would have classified it if I built it if I was working for the government and built that. I'd be like, all right, well, for now, because they're probably all like erring on the side of caution, and then if the Chinese are like, we have it, then they'll be like, well, we have it too, I guess. But nobody wants to say it first. Yeah.
Like, we had that. Like, the Chinese are gonna be like, we figured out warp technology. Trump's gonna be like, we figured it out 10 years ago. Sorry.
Yeah.
You know
and
what?
Here's
We're
the
better
demonstration.
than you.
And
Let me ask
eventually,
you, if you were like a black project engineer, you worked on this, like magic technology, alien technology, call it whatever you want to call it. Would you come out as a whistleblower?
No.
Would you?
No.
Yeah. Why are we not?
No, because that it's like life and it's like the Manhattan Project. I wouldn't have blow the whistle on that either if I was working for that. I believe in the ethos of the United States: free speech, gun rights, property rights. I want to do whatever I can to uphold that. If it means giving us the best military on the planet, giving us an edge, within the AI fusion race, I'm down.
Yeah, you know what? I mean, I agree the same way. That's why it makes it so hard. Is that like I don't even like doing this, but at the same time, it's like, people deserve to know about this science, about the technology. That's why the first question is like, where is the line between this? Because I also want us to have this technology. I want America to be the #1 country. But I also like, on the view of this, you're like, okay, we've got warp drive technology, maybe wormhole technology, gravity manipulation, and free energy technology. I wonder, how we have to be able to get some of this to the public people. I mean, at some point, you can't hide this forever.
Yeah,
so,
and relying on the government, or just because they're deep state and have access to the tech when they were kids, and now they get to learn about it, and their dads had money and now they have money. Just because they have it doesn't mean that's the best setup. It might be better for the populace to have it. So,
and that's the big catch-20, or I don't know if it's a catch-22, but that's the big struggle that we're in. Because I agree with you, I would never go whistleblower either. If I was in Black Project, I wouldn't even have a social media account. I wouldn't do any of this stuff at all. Because I do think it harms national security. And I think that if certain countries, certain cultures have access to this technology, I think the planet's definitely doomed, no question. But, it's a moral conundrum, because we are talking about the ability to kind of end poverty. The big thing for me is this. If America has this technology, why do we have so many homeless people? Why do we have so much struggling on this planet? Why does our country not look like ancient Rome with Colosseums and the Renaissance everywhere? That to me is the struggle. Is that I think that at a minimum we should be able to leverage the fact that we have magical technology.
I think it's because, well, one, they want to keep it secret. That's the main reason. Two is because we don't have the batteries yet to capacitate the power. Like, we can't run. Well, we have Tesla power walls. We're getting there, but like, really, really good batteries that you can charge once and then they run your house for 60 days or 600 years or whatever. Like, once we can build the batteries that can super capacitor batteries, graphene, cadmium, whatever the hell materials we're going to be using, probably crazy metamaterials, Cymatics and stuff, then I think the fusion will be like, what's the word? Functional. Like, for the common man, once they can store the battery, because then you won't have to give them the fusion reactor. They'll just be able to tap it in, get the power, and then benefit.
See, you're thinking about it pragmatically. Like, they're never going to give us a fusion reactor, or we're never going to get a portable fusion reactor, because then you could just turn it on, blow somebody up. But I could see they're going to give you a tap, right? They're going to say, here, you can tap into the energy and then you can fill up your local reserve, but it's not going to be enough to annihilate the planet, something like that. Where I think it was Hal Puthoff even talking about this, where it's almost as evil, maybe even more evil than how they portrayed in the movies, where he's like, guys, 0 point energy is real. It's coming out. This is a high risk venture, but it's high reward. And he's like, basically, everybody knows we can't just give everybody a 0 point energy device in their home. The way to do it is, like, when your old generators have to be replaced, just throw the old ones out and we'll give you new upgraded reactors. And no, we'll just never have to explain where that energy is coming from, right? And, well, if you save some money on it, well, you don't necessarily have to pass that savings on to the consumer, right? How does the consumer even know how much how much it costs you to produce the energy? That's what I think is really going on. And that's why I look at companies like Helium Fusion and I'm like, I've identified them as like, this is a company that the DOE is backing and stuff. And then I go, well, why is Peter Thiel like one of the major investors in this? And he's connected to the CIA and
oh yeah, and Palantir too. That's a good sign for fusion. Okay.
Yeah. And this is why I tell people, like, look, this isn't stock advice, but when Helium Fusion goes IPO, just go look at Palantir's stock price and what's happened to them as well. It's like, it feels like some of these companies are being kind of selected as because they know or they have the right connections. And to kind of like counter a point that Elon Musk made, Elon's like, why don't they compete with me? Well, just like you said before about like, why don't they reveal this technology or let us have it? Because then it would reveal the technology, right? So that's why they can't compete with it. But they also don't care about being $400-500 billion, richest people in the world. Give me $1 billion and I'm good. I'll go disappear. You never have to know my name, right? So that's the way it seems to work behind the scenes. But if people pay attention, I mean, I think you can see it happening.
So you're saying Elon's like, why won't they compete with my space program? Basically, is where he's at,
yeah.
and they're but secretly building drones that can go underwater and fly into space.
Yeah, exactly. Yeah, and I don't know. The space part's weird. Like, I want to broach this topic with you a little bit too. That the more I research these plasma drones and stuff, I'm going like, do these even operate in outer space? Because I think they're using something called an air-breathing system, magnetohydrodynamic system, which means they're basically using either the air or the water as either a fuel source or as like a catalyst in the reaction, so that they don't have to have that stuff on board. Well, outer space doesn't have nearly as much as like the air or like water. So there's two ways to look at it. One would be that like you don't need that much stuff in outer space because you're just like floating through the air, floating through space, right? But the other view of it is, well, even if you lose like a tiny bit of your matter, your energy, then over a long distance, you're going to lose everything before you get there, right? So I don't know if they can really be used.
It sounds like a local defense tool. Like I think it makes sense for planets to have local defense drones that are just plasma orbiting and protecting the atmosphere. That makes sense.
That's what I thought those New Jersey drones were. Actually, I was on with Clint Russell. You know him, right? That was, he and I did like really great live stream where we were talking about that New Jersey drone thing back in December. And I was like, I think they're like a defense mechanism. Like, what if they're just drones sitting around their defense network where like if someone shoots a hypersonic at us, our drones just intercept it and like wormhole it to the sun or something.
Or right? like an asteroid or something.
Yeah,
the drones could go
absolutely, right? Like the Apophis asteroid that I think is like 2029 or something like that. I'm not afraid of that because we got plasma drones that are just flying around that can, intercept stuff anywhere that we need to. But this means too, this is something that I learned from old anime shows, is that the smartest anime shows would be like the ones where the guy's like trying to understand the villain and like what his power is and like what his weakness is in his power. That's how, when I look at like the teleportation technology, I was like, what are the limits to this? Turns out there's a lot of limits to it. It's not just like, oh, I can just zap and just now I'm on the moon and now I'm back. Turns out it's like a one-way trip kind of situation. Like you zap here and now you're over here. But now you have to do it again if you want to go, somewhere else.
You know where I'm at with wormhole? Maybe you have more to say. Is
Sure.
Charged black holes. I'm not sure if you're familiar with the charged black hole. It's different than a regular black hole. It's like rotating, and I think it's been woken up. I think it's a teleportation mechanism. If you travel through a charged black hole, it will super accelerate you through that singularity. You'll go through so tight and be shot out so fast afterwards. You'll super accelerate towards the first star you hit, and then it'll slow you down and you'll stop in front of it. And I think that's literally, people will aim towards stars they'll put the charged black hole between them and the star, and they'll go through it, and that will teleport them to the star. And that we can actually charge our black hole, Sagittarius B, I think, is at the center of our galaxy. We have a black hole, but it's not charged up yet. So I think we can charge that thing and use it as a teleportation mechanism. Or whatever, a super accelerator, basically. Not really teleporting, but it's at that speed, it's hard to tell the difference.
Yeah, Leonard Susskind and Juan Maldacena, they believe that the black holes are quantum entangled. But there's an interesting theory that I hadn't seen before I read it yesterday, which was that what if the black hole doesn't have perfect entanglement? Like, the difference between a black hole and a wormhole would be when you create a wormhole, like I'm zapping this airplane here and it's reappearing over here. But what if when the black hole pulls in matter, it rips it out or shoots it out like a sprinkler? So it's creating multiple entanglements, but it's they're not all together anymore at that point. And what if that's the difference in that a wormhole is like a black hole, but it's like a stabilized temporary black hole, like this temporary rip you make, whereas a black hole is like this huge amount of mass that's just anything that comes in just gets ripped and shredded to pieces.
Has the scientific community located any wormholes yet?
Well, I don't know how we would even do that. That's the problem, because even if you see a black hole, okay, well, where is it coming out? Because what have we learned from entanglement? It could be anywhere. It could be literally anywhere. So I think we probably will find some, because I personally think that these wormholes and black holes exist. But the question is, are they cosmological phenomenon other than black holes, or are they purely a laboratory produced phenomenon, right?
The wormhole. What is it exactly? What's the difference between a worm? Do you know what the theoretical working definition of a wormhole is?
Yeah, it's just a bridge between 2 points in space and time. And so you can't obviously really... We have to only imagine it metaphysically because we can't see an extra dimension. But usually they represent it as two flat surfaces and then a tunnel between the two surfaces like this, right? And so it's this conceptual view that, like I was saying before, is that space-time is flat. I think it's been proven that space-time is actually flat. We don't really agree, and flat earthers are probably going to have a field day with this. But if space-time is flat, we just don't perceive it as flat. And if it's flat, then you can just bend it like this, and now the points that were previously not connected are connected. Now, that seems super weird to us because that's not how we observe reality around us. But that's because all of space-time around us is in equilibrium. It's all perfectly equilibrium. But if we rip that out of equilibrium, then we start to see these weird effects. But if it's true, if wormholes are real, then I think it proves Ben Rich is right, that all points in space and time are actually really connected. We just don't perceive them as being connected.
And motion and time and space and speed and all that, if you're in deep space with no reference point and it's black everywhere all around you, if you start going faster, you won't know it because there's no perceptual inertia. I don't even think there's inertia if there's no relative space. I don't think.
Well, that's the problem. Yeah, go ahead.
There is technically inertia, but you wouldn't perceive it. So and then your distance would be shorter, but you wouldn't have realized it was because you were going faster and didn't know it.
Yeah, it turns out a lot of this stuff is illusion, like cloaking or the illusion of distance, or when something gets smaller when it gets further away. It turns out these effects, while they seem illusionary, they're also just physically real as well. So if you contract or expand space because of relativity, you actually do change physical properties. One of the things that was being talked about, I think Richard Van Durick, he was making waves because he was talking about alien metamaterials or something like that. I don't know about all his alien metamaterial claims, but he knows about electromagnetism and gravity. And he was saying that, well, if you have length contraction or length expansion from general relativity, from things moving at relative speeds, then you can have current actually increase. From the perception of current, if I'm looking at an object, the electricity being formed will look like it's going up if you have length contraction or expansion happening. And he explains this from the perception of the electrons. And you're like, wow, okay, yeah. So general relativity actually starts to get really weird. And this could even explain, why do we have it? Imagine this cube of space-time. If I squeeze this cube of space-time, what's going to happen? What I would imagine is whatever's inside this cube of space-time is going to get pushed out. It's going to get pushed out, squeezed out. So if I have contraction of space-time, what do I think should be happening? Well, I think energy should be getting shot out, probably in the form of photons. So personally, that's how my view of the universe is. I think the 0-point energy is filled with this invisible energy that's in equilibrium, and if you squeeze it, you get light.
Oh, well, that's sonoluminescence then, I guess. You're squeezing the bubble underwater. You're creating a vacuum. Well, you're what is it? You're running a vibration through and creating a bubble, which then the pressure, the squeezing of the pressure, releases a photon. Seems to.
Yeah. So sonoluminescence, you take water and you just shoot sound, create a standing wave in the middle of your sound and of your water, and the sound will actually create light. Light actually gets formed, and it's because it creates a cavitation, an implosive effect that produces light. Science struggles to understand why that's the case and how there could be so much energy that light is being released while like the glass that's containing the water doesn't break, or why the water doesn't boil. Why does the water not boil? You've got light being produced in the middle of this, but the water's not boiling. Some people wonder, is fusion happening in sonoluminescence? And so I think that the reason why I love those experiments is that when I was digging through the science, trying to figure out like are they really hiding gravity, whatever, you find all these experiments that like have no like palatable conventional explanation. And that's why, part of the reason why I'm absolutely convinced that all this science is real is that when you look at the underlying thread of it, you find out that it goes back to Tesla. It goes back to Maxwell's original equations before they got reduced, as we threw out this scalar potential because we didn't see it. We didn't see it out there. Kind of like how we don't see wormholes out there. But that doesn't mean they're not real. The math says that they should exist.
Sure.
So the scalar potential is real too. Maybe we just didn't find the right effect to see it. Maybe it's mostly a lab-produced effect.
And this is what? The effect of what exactly? That we're within?
The scalar potential is like the effect of the medium itself. So like the effect of, and I believe the scalar potential gets seen more when you you create an electric system and you shoot the voltage up super, super high, like above 30, 50,000 volts. Is now that scalar potential that was really, really tiny before. Now you can actually see measurable effects related to it.
And a common example of that is I was up hiking up in the clouds. I was up in the mountains. It was foggy. I didn't know it was foggy because I was up there. It just looked normal. And I was walking and I'm like, why am I dripping with sweat? Literally as if I'd been in the pool swimming in my clothing. I was dripping. My friend was like, you're dripping, like drip, 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 drip. I'm like, why? Because the medium I was in, imperceivably wet. I didn't know because I was inside of it. I couldn't see it. Exactly the same kind of thing with space-time. There's so much potential energy in this medium that we don't perceive because we're in it.
And that's what allows for really all of this science to be possible, of free energy, of over unity, of fusion. I think that if there wasn't a medium, we wouldn't even be digging it. We wouldn't be trying to do fusion. I don't think fusion would be possible if there wasn't a medium of energy. I mean, you'd have to be pumping in all your fuel source conventionally, which I don't know how that could ever achieve over unity from a conceptual viewpoint if space is empty. But maybe we can do it that way. So go ahead.
I appreciate that you talked about distance contracting and expanding distance and that producing an electrical charge, or even the perception of expanding and contracting distance that could produce an electrical charge. I'm going to sleep on that one. That's really cool.
Definitely want to check out the Paul Thibodeau graphene thermal thing, which is really cool because essentially what he's created is a battery that the battery's default state is not zero. The battery's default state is, pick a voltage number. It doesn't matter, right? Because what that would mean is that you can sap energy off of it, and it always tries to go back to that equilibrium state. Yeah. How crazy is that?
A self-charging battery.
Self-charging battery, yeah.
Nice job, Thibodeau.
Paul Thibodeau. Yeah, I saw that one. I'm just like, wow. That was a type of... And so this is why I try to tell people, like, there's so many different conceptual viewpoints of free energy devices. One of them is just a battery that just never runs out. And so he's created an asymmetrical system that its equilibrium is not zero. And of course, every physicist that was in the presentation is going, how is this not violating the laws of thermodynamics? And he says, well, because it's basically just harnessing Brownian motion from the thermal ambient temperature. Like if you do the equations, the math shows it should work. They built a microchip. Microchip shows that it works. What else do you want, right?
And they created nuclear batteries they were doing with like they have like nuclear waste. They put in glass or diamond or something, and it produces exactly the same kind of piezoelectric
that's
pressure.
The stuff where I think you're talking about, where they're using the word nuclear, I think, a little cleverly, where like I think they're like doing transmutation, and they're just been like, yeah, it's just nuclear, because technically it is nuclear, but you're like, how are you doing it and how efficiently are you doing it? right? Like, because you could theoretically be doing this super efficiently, making like tons of money and just producing stuff that would people would be saying is violating, the laws of physics, violating the laws of thermodynamics. But yeah, I think that they're just doing it, and they're doing it quietly, and then they've got contracts with either the government or other entities. But just
and then they'll break off. They'll break off like that little one for the public and be like, "Hey, look what we figured out. You can maybe charge your iPhone with this." Okay.
Exactly. And now, when we talk about the companies, I think I know where your politics are. You think you're kind of more libertarian, kind of like I am, free speech, freedom of, expression, etc. Recently, the United States took control of part of Intel because I think they're a microchip manufacturer. I think a lot of what I've found out about this is like we're well past the days of like magnetic motors and these like free energy devices people were making that were like as big as a room. Now we're to the point of like people are making free energy devices on little microchips. So microchips are the future. There was actually somebody floating today the idea of Lockheed Martin being potentially nationalized as well. Apparently 97% of their revenue comes from the government. I didn't even know that about Lockheed Martin until today. So where do you stand on this like nationalization of companies under national, security or national defense? I mean, if the technology is that powerful, if we have this crazy, alien technology, 0.0 energy Tesla technology, is it right to nationalize them, or does free market win over?
I'm so glad you asked me this. I just posted this on Twitter before we went live, and it's that in the 20th century was basically the war between fascism and communism, and it was one or the other. Pick a side, and the Western powers chose fascism with the Federal Reserve and FDR, and it wasn't like Mussolini fascism. It wasn't that kind of violent kicking doors in Hitler fascism. It was British fascism. It was peaceful fascism, but it was better than communism, and fascism won. And we live in a fascist system where our government can print fake money and does so many businesses with corporations behind the scenes that is indicative of a fascist behavioral, but not on paper. They don't own any of the companies because that would be fascist. Well, anyway, Trump just did it blatantly in public for the first time. He's showing our fascist nature by using government funds, my money, to print fake money he basically made my money worth less to buy a company, and now they're talking about going full communist and owning businesses. It's insane. Like, we at least need a visage of a free economy, because
I think
Intel stock
Intel
stock went up 7% after he invested $8 billion or $10 billion. That's playing favorites in the market. What the hell's going to happen to the other chip manufacturers now?
How's nobody talking about this? I'm sitting here wondering, like, we just took over part of a chip manufacturer and nobody's saying a word about it. We are 100% playing favorites. I mean, there's no debate. We're playing favorites. Of course their stock went up. The first thing I did was look at their stock. I'm like, this must have sent their stock up. It's like, so, and I guess I can see it from a national security perspective, but I mean, the public that's not been researching this stuff, they should be all over wondering what's going on here. Like, what's the justification for doing this? And how do we, if now that we've set this precedent, now what, right? Why aren't we taking over Lockheed Martin? Why aren't we taking over Sierra Nevada Corporation? Why not taking over Battelle Institute? Like, there's so many companies that are defense contractors that are basically all their money comes directly from the U.S. government. Why aren't they taking over? Right?
Yeah, because that would be purely fascist or a communistic dictatorship if they were to try to do something like that and ruin the free market. And like, the thing I remember from time to time is that most people are not really smart. There are there are people that are really smart, and they're considered really smart because there aren't that many of them, so they're put in that category of really smart. And a lot of times people in the government, that you get that same percentage. Maybe you get some people in government. They're very charismatic, people in government, a lot of them, especially the ones that speak for a living. Charisma and intelligence are not the same thing. Intelligence and wisdom aren't the same thing. You might be able to remember what you were told to do and do it, and have high intelligence and great memory recall with no ability to discern if what you're doing is right or wrong because you don't have any wisdom. So we have to remember that just because they're people and they're given this badge of authority doesn't mean that they're good or intelligent or wise, and we have to keep these people in check.
That's the big problem. How do you keep them in check, especially if they have, magical technology? Let's just assume that these disclosure people are all telling the truth and that there's aliens here and we've got this alien technology. Well, things have gotten completely off the rails if that's the case. If they've got free energy, fusion technology, wormhole technology from aliens, from anything, how do you keep someone like that in check? You can't, right? I think they let the mask slip now where it's like, we just dunked on Iran. Putin just came and visited us. When was the last time Putin came to America? He just came to
10
America,
years.
basically bent the knee. I know people don't want to agree that he bent the knee, but I think he did. And then now we're also just, nationalizing chip manufacturers. So I look at this, I go, we're letting the mask slip here. And like, this is this type of stuff I would think would need to happen to put safeguards in place so that if we did want to release any of this technology, we aren't going to be able to destroy ourselves. And then America will feel safe that like China is not going to get our super advanced microchips or whatever that's going on.
You think the safeguard is purchasing the private companies so that the other, because I'm like, fascism isn't always evil. This is another thing I wrestle with. It's not always evil. Sometimes fascism can be good. You want to make that dumb argument. It's true. Sometimes you can use fascist tactics to create a stable, healthy system for people. Even at we're still conquering and absorbing resources from overseas. That's probably how we're able to maintain fiat fascism. But it doesn't mean it's evil just because it's fascist. So there is the argument that in the name of survival, we have to come together, use our government funds to buy. What the fuck? Have we not done this test? You buy 10% first. Oh, it's not real communism. It's only 10%. He doesn't have a controlling share. Yeah, not today.
Yeah, well, I mean, that company can never fail now, right? Because we've just bought 10% of them, so they will obviously never fail anymore. So yeah, I mean, it's ridiculous, the whole idea that we're just buying this stuff, these companies up. But I guess the last part would be like, well, what really is even disclosure at this point? Like, if we assume that let's just assume that there's aliens and we've got this technology or what have you. Like, how do you even define disclosure anymore? This is why I came up with this term called woke disclosure, because I think the woke disclosure people look at kind of what we laid out here, and they come to a similar conclusion. Like, we can't have all this. There's certain stuff that's got to be kept secret for national security, but they got to do something. It's like COVID, right? We have to do something. It's like a cold virus. There's nothing we can do. It's a cold virus, man. We have to do something. Make everyone wear masks. Just make everyone wear masks. We got to do something, right? I feel like they are doing the same thing with the aliens. They're going, we have to do something. Okay, just tell everybody aliens are real. Look, we can do that. That's not going to hurt national security. No one's going to make a super weapon out of that, right? Just tell aliens are real. The problem with that is it's so stupid. Like, okay, if aliens are real, how are they getting here? Like, where are they coming from exactly, and how are they getting here? And what is the fuel source for their magical UFOs that are flying around defying gravity, right? Like, those are my first three questions. So this is the part where I think that the whole woke disclosure thing is like, I think they just think they're better than us and they know better than us. And they might even be right, honestly. But I hate that viewpoint of this idea of like, they have to control our lives because we will blow ourselves up if we do. Like, honestly, for me, and I want to know your opinion, I just say if that's the case, if it's between us blowing ourselves up with this technology or just living a lie forever, I'm going to roll the dice, man. We're just going to blow ourselves. If that's the case, then that's how we go out. That's the end of our story, I guess.
Yeah,
that's kind of how I roll. What do you think?
Like, honesty and deceit. I used to think like honesty is the only way and deception is a mortal sin. It's not. The Catholic Church actually says honesty is not a virtue. Lying is not a sin to the Catholics. I mean, they don't care. Firstly, if aliens came here, they would not discern between our governments and our people. They would just they would just be here, and everyone would be like, "Wah!" It would be, that it wouldn't be like we secretly had a message with the guy we think might be able to tell the like, what the fuck? They're here for power. They're here to. Yeah. That's why they're here. They're here to expand. That's why they came. So whatever. But I agonize over the thing about the plebs, like the common man and then the elite, the royal and their subjects, the Romans called them the plebs, and then the leaders, whatever. But what it is generations of people with good nutrition develop very powerfully capable brains, good thinking, good intelligence, good wisdom, and then their children have good intelligence, and then there are family lines and communities of people that have had excellent nutrition over generations, so they're very equipped to organize and lead and run things. I get it. But that doesn't mean that other people can't. It just means that maybe they were dealt a bad hand coming in or dealt like a non-nutritious brain matter, body. Now, but then you got to think, well, they're still animals. Humans are animals. And a dumb animal is a very dangerous creature. You gotta just play real cards as they're dealt, and that is a true fact of nature. So I hate the idea of keeping things from people, man, especially when I see someone that I know could be great and they haven't become great yet, but they're not great yet. and I can't treat them like they are. So,
So what do you think? What do you pick then? If it's choices between ignorant bliss, living the world that we're in right now, our 21st century world, or taking the risk that we destroy ourselves, but we get Star Trek technology, wormholes, warp drives, even replicators, not immediately, but soon. Which one are you going to choose? Which one do you choose?
I'm interested in the risky path, but we have to discuss the risk. What's the calculation here? Now let's build a system of risk management and go from there.
And that's where I think that's a good spot to kind of leave the conversation today, because this is what I would say that I would hope that you would take from this as somebody that is on with Tim Pool all the time, talking to these Congress people that are looking at disclosure and what have you. I think the conversation has to become bigger than just aliens, right? The conversation has to become more about, okay, what comes with that? What kind of technologies come with that? And then what do those technologies mean if they really are free energy technologies, these technologies that are like Star Trek stuff? Then what is that discussion? Like, how do we put those guardrails up so that we can get these technologies to humanity in a safe way where we mitigate the risk, right?
Yeah, man. I don't know why I think of the CCP as the boogeyman. I don't like having a boogeyman on planet Earth. I don't think we need to have a boogeyman. I think that's just kind of human nature. We're so used to it genetically from always fighting against this animal coming to try and eat my family. I don't think we have to live like that all the time anyway, but I just imagined like a virulent, angry regime that's hell-bent on destroying everyone, getting access to some superpower. But if it's going to happen, living in ignorant bliss doesn't necessarily make it not happen.
Kick the can down the road, right? Like, that's not really solve anything in the long run. Let me ask you one other question.
Oh, yeah.
Do you remember a time when China wasn't our adversary? Because I feel like I was younger, even in my 20s, China wasn't even our adversary.
They were never our adversary. They did Tiananmen Square, and it was like, what the fuck? It was obvious they were completely batshit psycho when they massacred all those students for rising up in protest at Tiananmen Square. I thought that was okay, these guys are off the book evil to do that to their populace. That's terrifying that they would a government would do that to their populace. That's what I took in the early 90s from the CCP, and then never had a problem with them. I've always loved. I know Chinese products are shitty and cheap. I don't buy them. I try not to buy them. I love China, the history of China, the Han Dynasty. Romance of the Three Kingdoms is a huge part of my childhood. I read the novel twice. The game, Liu Bei, Cao Cao, Dong Zhao, all the characters. I identify with Chou Liang, this ancient teacher of the Chinese people who invented the repeating crossbow, and he could control the weather, as the story says, he could call lightning and things. I love China, Chinese history, and the people. One-on-one when I meet them, I'm just always concerned with communism and central governments. Trying to centralize authority is insane to me, which is like buying intel with our government. It's insane to me. Okay, I agree. I don't even think they're our villain. And you know what? But Scott Horton on Lex Friedman just did a 10-hour interview with Lex Friedman talking about what caused the War of Terror. Basically starts with the Iranian regime in 1979, goes all the way. I've only watched a couple hours, but he said in the 50s and 60s when they were developing counter-nuclear war protocols in the United States, if the Soviets go to nuclear war with the United States, the plan was we're going to nuke every metropolitan city in the Soviet Union, and we're going to nuke every metropolitan city in China. Because if the Russians and us are going to take ourselves down, there's no way in hell we're letting those commie bastards take this planet. And that's the U.S. protocol is basically, if anything goes down, we're wiping all of China out. And I think the Chinese know that.
Yeah, and I think they all know that, and I think that's the reason why you can't have this technology comes out, because if somebody has, a super black hole weapon, then everybody's going to it's going to become a Mexican standoff, right? And now we're back at a point where anybody does anything, the whole planet's destroyed. So, oh, man. And this is where I kind of wonder about the China question. They are communists, no question. They're a controlled government. But it's if you knew about free energy technology, if you knew about the dangers of this technology, and you were one of those elites, you probably would do this. I think most of us would do the same thing. That's the scary part. And so then it's a matter of just how do we change the incentive structures in a positive way where we can have some of this stuff, an actual disclosure of information, of technology.
Reducing fuel costs is a big part of it, which is why the hydrogen revolution excites me, whether that's through fusing hydrogen into helium or using hydrogen gas as a propellant or as an excitator for heat to get propulsion. The hydrogen revolution, reducing the cost of fuel will reduce the real national debt from 36 trillion on paper to if fuel's a tenth of the cost, then our national debt may say 36 trillion. It's a tenth of that in reality. Like, and that's a rough calculation, but you might pay $100, but the value, it's easier to get $100 because it's so much cheaper for your fuel. That's the point. And then that reduces global tension. And then as humans, we'll be able to reinvigorate the 21st century tech.
I'm with you. Until Saudi Arabia is like, wait, you don't need oil anymore? No, we hate you. We're going to blow you all up now. But no, I think that they're smart enough to like get on board with this before, like they're investing in this technology, I think, like already.
And honestly, you can use that flash joule process I was talking about where you electrocute carbon. You can do that to oil. You can put oil in a vacuum and electrocute it and turn it into graphene and get hydrogen. So it's still useful carbon. Like, you don't have to burn it for fuel. You can use it to create graphene, and then it's even better fuel in a lot of ways. And coal. Cool. You can do that with coal too.
Yeah, this was an awesome conversation, Ian. Go ahead. Do you want to shout out, any of the projects, anything you're working on?
Oh yeah. Well, I'm working on a lot of music behind the scenes. I got a movie upcoming that I'm producing right now, and obviously I'm working with Tim Pool all the time. I'll be on Friday, Timcast IRL on YouTube and Rumble. Timcast IRL at 8 p.m. Eastern Standard Time. You can always follow me, Ian Crossland, on really any social media networks that you find me on. I do Rumble, YouTube, Facebook, Twitter, X, Instagram. Those are my top, I think at the moment, top 5. Mines, follow me on Mines. Happy to be here, Ashton, man. This is great, man.
Yeah, this was awesome. So, yeah, this was great. Let's meet up again sometime soon, play some Magic cards, and let's be in touch, and we'll talk more science. This was an awesome conversation.
Excellent, man. See ya.
Take it easy. Later.